Our final presenter is going to be Jennifer Rackliffe. She's a PhD candidate in Ag and Biological Engineering at Purdue. She's going to be speaking on considerations for co-digestion in agricultural AD systems. So Jennifer, you're on.
Great, thank you so much. Get my screen up.
And you look good, we can see it.
Visible? Awesome,
Yep.
fantastic. Okay, so thanks to all the previous speakers, these have been really fantastic and have really fed into actually a lot of the stuff that I'm going to be talking about today. Before I get started, there's just a few things I wanted to mention. First of all, the SARE program, the Sustainable Agriculture Research and Education Program, has actually been one of the primary funders of the research that I'll be talking about. But they're also, part of the reason I wanted to mention them right now is because they're also one of the motivating factors behind these two webinars that we just did. So wanted to thank that program for that. Also wanted to acknowledge we're actually working on this research with a local agricultural anaerobic digester, Biotown Ag, here in Indiana. And so some of the feedstocks that I'll be talking about, those are actual real feedstocks that we got from them directly. Those are feedstocks that they're using in their digesters. And of course, I've received a lot of help from other people as well in the lab. So wanted to kind of, what co-digestion has been mentioned in various forms several times today, actually, by the other speakers. And so I'll give just a little bit more of an introduction to what co-digestion is and some of the benefits and pros and cons. And then, as you probably guessed, as a PhD student, most of what I do is research. So I do lab work with co-digestion, and I'll spend a good portion of my presentation discussing some of the science and research aspects of co-digestion. And I'm hoping to spend the last part of the presentation discussing more specifics about actual practical aspects of what this means for a real digester, what practical steps can be taken to benefit from co-digestion or to mitigate any potential problems. So first of all, what is co-digestion? I wanted to acknowledge before I get too far, the really fantastic presentation we had from Chad Antle during our last webinar about a month ago. He did a great job talking about some of the practical digester scale advice when considering possibly utilizing co-digestion in a digester. And so I would, if you weren't able to attend our last webinar, I would highly recommend checking out his video. Like Kenny mentioned, these videos will be posted on that website. I've put the link in the chat as well. After the event, so the previous videos are already on the website. Also, for any speakers that have shared their slides with us, we've also posted those as well. And that will be the case for this webinar as well. So co-digestion is basically just anaerobic digestion of more than one feedstock. When you're talking from an agricultural perspective, it's not super uncommon to just do anaerobic digestion of manure only. But as has been mentioned a few times now by Dr. Lau and by John, that is not always economically feasible for some farms, particularly smaller farms, that limit in terms of revenue can be cost prohibitive. So, but from an industrial side, this is actually a question that got brought up during our last webinar. And so I thought it was a really fantastic question and wanted to kind of highlight some of the the industrial side, that some of the industrial challenges that come when, if you consider, so why don't companies that are producing some kind of organic waste, why don't they just digest it themselves if it's so great to do this? And there's a lot of possible reasons for that, since there are a large variety of feedstocks with very diverse characteristics. It's really going to depend on the company itself. But in many cases, each individual company isn't necessarily going to have enough supply of a feedstock to make that economically feasible for them as well. Also, some feedstocks are just not really fantastic to digest by themselves, and I'll show some examples of those in a little bit. So co-digestion is one possible tool. It's not necessarily a cure-all for every situation, but it is one possible tool that can help bridge the gap, both on the agricultural side and on the industrial side. The feedstocks that I primarily work with are more kind of industrial feedstocks, but as other speakers have mentioned, agricultural residues are also a really fantastic co-digestion feedstock. Also various forms of food waste, particularly from like large cafeterias or restaurants or stuff like that. Those are also viable feedstocks. So I just wanted to mention that, since the rest of my presentation will kind of be focused on some of the specific feedstocks that I personally work with. So from the agriculture side, bringing in tipping fees and increasing energy production can make the economics look a lot more attractive for doing anaerobic digestion in general on a farm. From the industrial side as well, like I mentioned, some of those feedstocks are just not great to do by themselves, or you just don't have enough for it to be economically feasible. And combining that with something really stable and really consistent like manure can be really beneficial from the digester side of it. So then in terms of research questions, how they behave together and how you might go about predicting what kind of gas you might get out of it, those are the questions that I focus on in my research. So these visuals that I'm going to show are even still kind of understatements, but balance is kind of a recurring theme throughout this presentation. So I wanted to give sort of a quick visual of comparative complexity. I think from the outside, when you just explain to someone what anaerobic digestion is, sometimes it can look, really pretty simple. You put stuff in, you get stuff out, and it's great. As the speakers today have highlighted really well, I feel like there's actually a lot of moving parts that have to be balanced and have to be considered. And just looking, from the outside, looking in, that's not necessarily always obvious, but if any of you out there are operating or working with digesters, I'm sure even this visual's a little bit of an understatement. Co-digestion, I think a lot of people kind of understand, if you're adding more things, then it is going to be a bit more complex. But as I'll talk about during the rest of this presentation, some of the things that get added in are, things that you might not necessarily expect. And so it feels like a real balancing act. But I'm hoping to shed some light on some of the things that might be causes for concern if you are considering co-digestion in yourself, if you have a farm digester, or if you're working with someone who is looking into co-digestion as a possibility. There are some real benefits. So for this next part, I'll be discussing what my research has revealed about the pros and cons of co-digestion. So just to give you a little bit of a background of what I mean when I talk about experiments doing co-digestion, I do in my lab, we do biomethane potential tests with these parameters. We're using these 1 liter batch digesters. So, we just have these these little 1 liter digesters that we stick inoculum and some kind of feedstock or multiple feedstocks in, depending on whether we're doing monodigestion to give us a baseline or co-digestion to see what changes when we do that combination. And then this picture doesn't show yet, but we cap these digesters obviously to keep them anaerobic and we collect gas. We collect the gas in gas bags. With these digesters, we're doing them mesophilically, so we're keeping them just under 100 degrees Fahrenheit. We're using water baths to maintain that temperature. So this is one of the some of the first results that I wanted to highlight. We tested more than 5 feedstocks, but these are the 5 primary feedstocks that we've spent the most time with. And as you can see, not only do the feedstocks behave very differently from each other, depending on what they are, some also vary pretty dramatically from themselves, depending on the experiment and depending on when we collected that sample, which batch we collected that sample from. So manure on the whole has been very consistent from batch to batch, and that's not too surprising. Manure is generally a pretty consistent feedstock, which is one of the things that makes it so fantastic for anaerobic digestion. Not only do you know what you've got coming in, but you also have a great deal of confidence that your manure is going to do what you expect it to do. However, as you can see from some of these other industrial feedstocks, the slaughterhouse waste, the soap stock, and the filter slurry, all depending on the experiment we did, sometimes exhibited some very different results, not just in terms of ultimate yield, but also in terms of how long the lag phase was leading up to that. And our testing, I don't have a slide to show this, but our testing of some of the other parameters has also revealed this to be the case. It's not just, that they behave differently in the digesters, but they are varying actually fairly substantially in some other key parameters, key physical and chemical parameters that, and I'll talk a little bit more later about how you might deal with that if that ends up being an issue with feedstocks that you're using. So how much gas is it possible to get? Generally speaking, we can at least assume that you have additive biomethane potential, that you can get, 1 + 1 = 2. You put a certain amount of methane in, you put a certain amount of another feedstock in, say starch in, and you get out what they would have each been if you added them together. All of my graphs I talk about in terms of yield, meaning gas per amount of stuff put in. So for example, this graph, this is just a visual graph rather than showing necessarily specific data yet. But an additive prediction would be that would be at a weighted average somewhere in the middle, basically, because you're adding more stuff, but if one is producing less gas per amount of stuff, we're not. You might be overall producing more gas, but the amount of gas per stuff would go down. However, that I just wanted to emphasize that when you see that additive, like if I say it's an additive prediction, what I mean is that you are getting 1 + 1 = 2. You're not getting less if you put more stuff in. So just, like in a lab scale, you might put less manure in because you're also adding also adding something else in. But in a full scale digester, presumably you're using all of your manure still, and you're just adding some extra stuff on top of that. And so you would be getting more gas. That's kind of the point of this. So sometimes we see synergy 1 + 1 = 3 or 4 or 2.5 or something like that. Sometimes you can get more gas or at least get it faster, depending on what you put in. So that would be, if you see a line or points on a graph anywhere above that additive prediction, that would mean that we're actually improving on what you would have been getting independently from each feedstock. And there are a lot of possible reasons for that. I'm not going to go into to all of those today, but just wanted you to be aware that that is something that we sometimes see. So this is just one example of our experimental results showing how synergy can be possible. We've also seen, I'll walk through this example and talk about some other things that we've seen. So this is an example of manure and starch. The manure is this brown line at the top, and the starch is that lower line down below. So then we had 2 different treatments. One was a 1-to-1 ratio of manure to starch. And so of course that's going to be somewhere about halfway in between. This was a higher ratio of manure to starch. So we're predicting additively that we're going to get an improvement there. What we found with our digesters, and this was done with 3 digesters in this treatment, is that with our 1-to-1 ratio, we actually saw substantial improvement, not just in terms of ultimate yield, as you can see, there's a big difference there, but also the gas was produced significantly faster as well. And so that's a pretty good indicator of possible synergy between the manure and starch treatments. In this case, there was a lot of variability between the 3 digesters, and that sometimes happens in lab scale digestion, or even in full scale digestion, really. So as you can see here, our overall experimental average was above our additive prediction, but there was enough variability that we can't necessarily say that we were seeing synergy in this particular instance, but I think we can be pretty confident that we're at least seeing additivity, which like I mentioned before, is pretty normal. So I just once again just showing all of the data points there, but I wanted to mention this is just really just one example. I don't want to spend this entire time talking about our experimental results. So this is just an example of how synergy can be possible, but we have also seen lag phases erased actually. So some of those examples that I showed earlier with some of those feedstocks that had really long lag phases, that is also something that we've seen a big reduction in. So if these results are interesting to you, I'm happy to talk to you offline give more details about that. But one point I wanted to bring up is faster always better. I sometimes talk about these results like, look, you can produce the gas faster and get more of it. And getting more of it, generally most people accept that's good. But is getting more gas faster always better? And in reality, that is going to depend on you and your system, if it's ready or not. So just like in lab digesters, like I've shown here, and these examples are actually just from, these are 5-liter gas bags, and this is the gas that is produced overnight, like 12 hours or less. So, maxing out that 5-liter gas bag from 1-liter digester, that's pretty intense, and that was not what we were anticipating. And so in some cases, we were not necessarily ready. So in a lab setting, this is inconvenient and obviously messy, as you can see here, but it's not the end of the world. But producing gas too quickly in full-scale digesters can cause some pretty serious problems sometimes. Certainly can cause issues with acidification, but also if it leads to actually needing to flare the gas, then you're losing out on that gas potential that you otherwise would have been benefiting from. So faster can be better, but as long as you're ready for it. Foaming is not uncommon in anaerobic digestion. So this is, if you are familiar with anaerobic digestion systems, this is probably doesn't necessarily come as a surprise that you need to watch out for foaming. But what I wanted to mention here is that there's lots of possible causes for foaming, and the more feedstocks you add, there's just the more possibilities, more chances for those complexities and those causes to come up and to cause some real problems. And these are, once again, just some examples of some of the just from our lab, some of the examples that we saw of foaming and what it causes. And again, in a lab scale digester, it is not fun to have foaming. It is not enjoyable. It's very inconvenient, but it's a lot worse in a full scale digester if it causes issues with actual equipment to malfunction or need to be replaced or whatever. This is something that we're looking at, trying to look into more closely in our own research, and there is some other good research out there about the causes for foaming and how to deal with them. Another thing that we have been seeing a lot in our results is that as we balance nutrients, and of course with anaerobic digestion, it's pretty common to talk about balancing nutrients in terms of carbon to nitrogen ratio. So, probably any of you who are familiar with anaerobic digestion already, or compost, if that's something you're more familiar with, the 30-to-1 carbon to nitrogen ratio is something we talk about a lot, and that, or possibly a little lower, maybe 20-to-1, or possibly a little higher, but in general, talk a lot about that 30-to-1 ratio, and that is absolutely valid, absolutely true. But another thing that we sometimes that there's a growing body of research looking at is the balance of macronutrients, things like carbohydrates, proteins, and lipids, or lipids being fats, oils, and greases and stuff. And you talk about having a balanced diet being good for you. That's also, as far as we've seen so far, true of digesters as well. Lipids can produce a lot of biogas, which is fantastic. If what you're interested in is producing more biogas. But they also, at times, can cause inhibition. They can cause these long lag phases like you're seeing here. And starch, this is an example of one of our feedstocks, the starch, which has basically nothing besides carbohydrates. It produced gas very quickly, but also plateaued very quickly as well. And so manure is a good kind of base feedstock, even if it's not necessarily the majority of what your feedstocks are. It's a really good, solid foundation base feedstock because it's already relatively balanced in terms of some of these nutrients. And so then adding some of these other feedstocks in as well can be helpful from the perspective that you've already got something stable. So adding in some more of something can help just produce more gas rather than cause other problems. So in conclusion, for this research portion, wanted to just emphasize a couple of points. First of all, co-digestion does increase gas production most of the time, at least. Sometimes inhibition occurs, but generally speaking, co-digestion will increase your gas production, which, as we've mentioned previously in other with other presenters, gas production is often one of the primary goals. And so increasing gas production leads to more revenue, which is great. Synergy is also possible, although certainly not a guarantee by any means. And balance is key, not just for macronutrients, but also for micronutrients. If you are using significant amounts of manure in your digester, micronutrients will probably not be a big deal. But again, if your digester starts looking more and more like a mash of other things piled in, that might be something that you want to at least look into, consider, just to be careful that doesn't end up being a problem. Of course, high variability, inhibition, foaming, and feedstocks that digest quickly, as I've mentioned previously, can cause potential problems. And that's one of the things that I'll talk about towards the end here about possible solutions for those as well. So how do we translate this into full-scale digesters? One of the first things that I want to emphasize is that while laboratory research is interesting and can give us a lot of hints about what's going on, it does not translate perfectly by any means. So these are just some possible things that I've seen, not just with my own research, but also just from being in the field and hearing about what's going on with some of these full-scale digesters. But some things to consider if co-digestion is something that you're exploring as a possible option for your digester, or for if someone else that you're consulting with or whatever is exploring as an option as well. So I actually thought that it might make sense to kind of look at it in terms of a SWOT analysis, specifically where I'm going to be looking at the possible strengths and weaknesses of anaerobic digestion, anaerobic monodigestion, specifically manure only anaerobic digestion, and then looking at some of the opportunities and threats that might occur when adding in co-digestion. And I'm sure there are some of all four of these things that I have missed. So I'd actually appreciate if anyone with additional experience wants to throw in additional strengths, weaknesses, opportunities, or threats that they see in the chat as I go through some of these. So some of the strengths of manure-only anaerobic digestion: it's very consistent and known. Presumably, if you are running one of these, you already know what kind of manure you have to start out with, and how it does in an anaerobic digester. Manure has been extensively studied, and so it's fairly predictable for one thing, but also there's a lot of expertise already available out there on manure only anaerobic digestion. Some weaknesses we've discussed a little bit already. For one thing, if you are dependent on the gas from your manure only, that is a fixed amount, unless you add more animals, you've got a certain amount of manure, and that's not going to change. And that means that the gas that you can get out of that is also not going to change unless, maybe there's some treatment methods or something that you can do to increase the gas, but that's kind of a separate thing. Fertilizer, as Juliana mentioned earlier, and Dr. Lau as well a little bit. Extracting nutrients from the effluent can also possibly provide an additional revenue stream. But once again, what you've got coming out of the digester is going to depend on what you've got coming in. And if it's only manure, that's all you've got. Sometimes, and I'm not saying that this is always the case at all. I'm sure that most of the time it's not, but occasionally it can happen that there's actually that the digester was actually over-engineered a little bit for the capacity you had, or for the manure you had, and there might at times be additional unused digester capacity, in which case you know, missing out on the revenue that could be coming in from and offsetting those capital costs that have already been expended. So some opportunities that exist for co-digestion, additional revenue streams, like I mentioned earlier. Tipping fees is something I don't have a lot of personal experience with, so I can't go into a lot of detail on that aspect, but I would refer you back to Chad's presentation once again from that previous webinar. He gave a lot of really excellent details about tipping fees. Additional gas, of course, you know, you bring in something else and you're getting more gas, like we talked about earlier. Possibility for improving digester kinetics, as I mentioned before, which can be helpful. And if you are using your digestate already for something, maybe extracting out those nutrients for fertilizer, or you know, turning it into fiber products like Dr. Juliana mentioned, or whatever, that can, you know, that it provides an additional revenue stream as well. As John talked about pretty well, carbon credits are going to depend on the feedstock, although most of the time they would fall probably more into a D5 category, or even off the chart for RINs, which can actually be a threat, be one of those. It can disqualify you for carbon credits or shunt you into a lower category for carbon credits. And so that's something to be aware of. Although, as he mentioned, that sounds like it might be changing, which is exciting. So some other possible threats. Would you need some kind of retrofitting? That's going to depend a lot on what you've already got, and what kinds of feedstocks you're going to be bringing in. But that could possibly be an upfront capital cost that you want to consider. Inhibition and foaming are obviously things you want to avoid. This topic of dependence on a feedstock outside your control. One thing I wanted to mention about that is I heard stories of digesters that have been using a specific feedstock for a long time, and you know, the digester got used to it, and those microbes get used to eating a specific diet, and they adapt over time to diets. And one of even when you're giving them something that's good for them, big dramatic changes are one of the hardest things on a digester, just kind of in general. And so if, you know, say the company that was providing that feedstock goes under or pulls out of the contract or whatever, and your bugs are used to that, that can be a potential downside for your digester, and can cause some upsets. And so that's something to just be kind of careful about as you're considering which feedstock to add and how much of those other feedstocks as well. Additional digestate, if you're already maxed out on what you personally can land apply, or what you can give away to someone else, or and if you're not using it in another way, having more digestate coming out is not necessarily a great thing. So that's something to consider. And of course, the gas production as well. If you're producing too much gas, you're losing out on at a specific given time. It's so much that you have to flare it in order to get rid of it, because you can't, you know, sell it fast enough or use it fast enough or whatever. That is also losing out on possible revenue. So it's not all bad though. There are some steps that you can take to mitigate some of these problems. So in terms of inhibition or foaming, foaming is a challenge, and there's various ways to look into that. But dilution, you know, just putting in less of whatever specific feedstock is causing those problems, or looking a little bit more deeply to figure out what problems are arising and why. Those can be approaches to deal with those things. Like I mentioned, depending on a feedstock outside of your control can be challenging. Diversification can actually help a lot with that. If you're using not just one other feedstock, but several other feedstocks, that can really help a lot. Hopefully have a really stable base. And manure can sometimes provide that stable base depending on your system and how much and what else you're bringing in. But also, you know, if there's another company that you're considering working with that you're just really confident you'll have a good working relationship with for a long period of time, and they have a really stable feedstock, that could also be an option. Mixing pit is one that I'll mention a couple of times actually as a potential solution. I think this is probably a good idea sort of in general with co-digestion, but having a pit or a storage tank or whatever that you've got some options for homogenizing what goes into your digester before it goes in, possibly over a few days or so, that can really help with the stability for your digester, that reducing some of those potential issues that might cause problems for the microbes inside of the digesters. So I mentioned high variability in feedstocks earlier. Just being aware that is an issue can go a long ways. Doing a lot of testing up front can be very helpful. Again, tipping fees is not something that I have a lot of expertise in, but that could actually possibly be a leverage point maybe for adjusting some of those tipping fees, or negotiating tipping fees. If you are thinking about bringing in another feedstock and you've tested several batches of the feedstock and you see there is a lot of difference in what they might be giving you on a given day, there might be opportunities to leverage that and adjust the fees accordingly to help you on the other end make sure that your digester is healthy and producing the right amount of gas at the right amount of time at the right time, and so forth. Additional digestate I've mentioned a few times before, but this is something that came up in some of those other presentations as well, and I just wanted to highlight that it can often require more work in order to get it ready, but that digestate can be a real opportunity depending on what you're able to do, how the methods you're able to use to treat it and convert it into fertilizer, or extract nutrients from it and convert it into fertilizer. And as fertilizer costs go up worldwide, really, I think this is going to be an even better option in the future. If there are issues with carbon credits becoming disqualified because of that mixing, like John mentioned earlier, I've seen in the past that some people, and again, this is not going to be an option for everyone, but seen that some facilities already have multiple digester units, and they're able to adjust what goes into each digester in order to leverage, I guess, for lack of a better word, the most carbon credits that they possibly can. So once again, if you're having issues with gas, that mixing pit is going to be an option that will help with that as well. Storage tanks for the feedstocks coming in might be an option, although of course that would also contribute to capital costs, but that's something that might be worth considering. Of course, another thing I wanted to mention as well is that depending on the digester that you already have, this might not be possible, but there are some digestion facilities that actually do some amount of gas storage as well, that could help mitigate some of those issues that you might run into if your gas production is fluctuating somewhat. So specific steps you can take if this is something that you're considering, or you're advising someone who's considering this, doing research about the feedstock in advance, the company, knowing how much they're going to be bringing, how often, and what kinds of variability or contaminants might be involved. Testing those feedstocks in advance, I cannot emphasize enough how important this is, not just the kind of the standard solids, pH, carbon to nitrogen ratio. I think those are pretty common things, but we've been seeing some research in the field that indicate that knowing something about macromolecular composition can also be useful. And as far as I've seen it, it seems like that's still emerging in terms of the industry about whether or not that's something that people are looking at. So just wanted to mention that. Also, one possible option could be having someone, either a company or even a university, actually conduct a biomethane potential test, or even do a very simple biomethane potential test yourself, just to give you a rough idea of what to expect out of that feedstock. And once again, that's not going to be perfect, but it can at least give you some ideas of what might be happening, or what could possibly occur. And of course, adding any equipment or upgrading any equipment will lead to higher costs naturally, but that can also lead to greater revenue potentially, or avoid lost revenue from challenges that might come from co-digestion. So that's another thing to consider. So in conclusion, if you take anything away from this presentation, I hope you realize that co-digestion, while not certainly a cure-all, can potentially be a useful tool in your toolkit, as you are aware of what issues might arise. Lab testing, and particularly in advance of bringing in these additional feedstocks, isn't perfect, but it can certainly help avoid some problems. Even some very simple lab testing can give you some really interesting insights into what might happen in your digester, and balance is key. And with that, I would be happy to take any questions.